Hello everyone, welcome to YourPedia platform. I am your mentor Rohit Singh and today we are gonna be solving NPTEL assignment question of subject open channel flow of this booklet. So I have taken a question of open channel flow which is given on page number 237 as question number 2 of this booklet. So let us start this question. So here in the question number 2, they have told you that a partially open sluice gate discharges water into a rectangular channel. So basically a rectangular channel is given to you and a sluice gate is given on the rectangular channel, right? Tailwater depths are given to you as 3 meter and Froude number is 1 upon 2 root 2, right? So let us, and they have told you that a hydraulic jump is occurring at the downstream of the sluice gate, right? So let us draw a channel. So that let us suppose this is a channel which is a rectangular channel and this is bed of the channel and there is a sluice gate which is present on this channel, right? And so we can say that this will be the depth of the water on the upstream of this sluice gate, and since a hydraulic jump is getting formed at the downstream of the sluice gate, so let us draw a water profile on the downstream of the sluice gate, and that profile might be like this, correct? So along with that they have told you that the tailwater depth at this section, basically let us suppose that this section is second section, 2 section, and the depth of water at this section is 3 meter, which is given in the question. Along with that they have also told you that the Froude number is 1 upon 2 root 2. So Froude number is given to you as 1 upon 2 root 2 for this channel, and a hydraulic jump is formed at the vena contracta. Jet is coming out of the sluice gate. The sluice gate opening should be what? So they are asking you the sluice gate opening or the orifice opening, right? So they are asking you this, what will be the depth of at this section, right? And we know that the lowermost depth, this will be vena contracta. This point is known as vena contracta, right? So this is vena contracta. Let us suppose that this depth is y1 and this section is 1 section. So hydraulic jump is occurring from section 1 to section 2, right? Depths are given to you or at the tailwater depth, which is after the jump is occurring, as 3 meter along with Froude number, right? So let us first see which Froude number is this. So we know a hydraulic jump occurs. So basically hydraulic jump occurs when flow is converted from supercritical to subcritical flow, correct? Supercritical to subcritical flow, right? So when a supercritical flow gets converted to subcritical flow, then a hydraulic jump is occurred, right? So we know that for a supercritical flow, the Froude number is basically greater than 1, and for a subcritical flow the Froude number is less than 1. Is that clear? And since they have given you in the question that the Froude number is 1 upon 2 root 2, and you can see that 1 upon 2 root 2 will obviously be less than 1, correct? So Froude number which is 1 upon 2 root 2 and this is basically less than 1, hence this is subcritical flow, clear? So this is subcritical Froude number, right? So we know that a subcritical flow forms when after the jump, right? After the jump. Therefore this Froude number which is given as 1 upon 2 root 2 will be a Froude number at the section 2, since this is the section after occurring the hydraulic jump, right? So this will be 2 Froude number at section 2, and this is 1 upon 2 root 2. Is that clear? After that they are asking you to calculate the y depth. So in order to calculate the y depth, we can first calculate the y1 depth. So we know what we know is, as per Bellinger's formula. So there is a Bellinger's formula. As per Bellinger's formula, so there is a Bellinger's formula which says for horizontal horizontal and frictionless rectangular channel. So Bellingers gave an equation or a relationship for the depths before and after the jump for a horizontal frictionless rectangular channel as. So for horizontal frictionless channel, Bellingers gave an equation which is y1 upon y2 is equal to 1 upon 2 under root 1 plus 8 times FR at section 2 whole square minus 1. So this was the formula given by Bellingers for a horizontal frictionless rectangular channel. You can remember this formula like if this is y2, then we will use FR2. FR2 they have given you in the question. Basically FR2 we have just concluded that the Froude number which is given in the question is at the section 2 of this channel. So this is 1 upon 2 root 2. Y2 we already know which is 3 meters. So we can easily calculate the value of y1. So let us substitute the values and get the value of y1. So we know that y1 upon y2 is 3 meters is equal to 1 by 2 under root 1 plus 8 times FR2 square, which is 1 upon 2 root 2 whole square minus 1, right? So 1 upon 2 root 2 whole square is 8 only. So this will be 1 plus 8 into 1 upon 8 minus 1 into 1 by 2 will be equal to y1 upon 3, right? Solve this and you will get the value of y1, which is the depth of water before the hydraulic jump occurs, right? So from this you will get the depth of water before the hydraulic jump as, so y1 will come out to be equal to, 0.621 meter, and this is depth of water or depth of flow before hydraulic jump occurs, clear? So now we have calculated the y1 depth, right? So we can see, now we can note in this question that y1 we have just calculated as 0.621 meter, right? Now they have also provided you that the coefficient of contraction or CC is 0.9, and we know that coefficient of contraction is basically the ratio of area of vena contracta to the area of orifice, right? So area of vena contracta will be this area at section 1 and the area of orifice will be this area which is below the sluice gate, right? So let us derive an relation for that, right? So we know that CC is equal to area of vena contracta upon area of orifice. Is that clear? So this is the definition of coefficient of contraction. So let us suppose for unit width or for 1 meter width, let us find the area of section at vena contracta and the area of section at orifice. So CC will be equal to, if we suppose we take 1 meter depth, 1 meter width into area at vena contracta will be B into Y1 and the area of orifice will be B into Y, and width we have just taken as 1 meter for unit width. So B into Y1 will be the area of vena contracta and 1 into Y will be the area of orifice. Clear? So from this we can see that the CC value is equal to Y1 upon Y. So in this relation we know that the CC is given to us as 0.9 and Y1 we have just calculated as 0.621 meters. So from this we can easily calculate the depth of flow below the sluice gate, correct? So let us substitute these values and get the value of, so Cc is equal to y1 upon y, correct? So Cc is equal to y1 upon y, and Cc is mentioned in the question as 0.9. Y1 we have just calculated, so y1 we have just calculated as y1 is 0.621 meters. Is that clear? So y1 is 0.621 meters upon y we need to calculate, right? So y from this will come out to be equal to 0.69 meters. Clear? So now we have calculated the value of y, and this is basically the depth of flow. This is depth of flow below sluice gate, right? So the depth of flow below sluice gate is 0.69 meters. So let us come back to our options and see which option is correct. So they have given you A as 0.3 meter, B is 0.4 meter, C is 0.69 meter, and this is the correct option basically for this question. Therefore, the depth of flow below the sluice gate or the gate opening will be 0.69 meters, right? So this was a simple question asked on the basis of hydraulic jump, and also using the some properties or some principles of fluid mechanics, because the coefficient of contraction generally you study in fluid mechanics. So this was a wholesome question, right, of open channel flow. So I hope you understood this question. For more interesting questions and videos, keep watching, keep preparing. Thank you and have a nice day.